Guys, welcome back to another video. In this video, we're going to be talking about passive and active buzzers. So first, we're going to talk about what's the difference between both the buzzers, what are the both buzzers, and then we're going to go into a little bit more detail, and then we're going to write a code about how we use passive buzzers. So first, let's go ahead and start with our notes. So first thing I just want to let y'all know is that whenever we speak, we produce compressions and rarefactions in the air. So basically, it's just our voice. It creates vibrations in the ears, and these vibrations reach our ears, and they vibrate our eardrums, which is how we hear stuff. And I just want to talk about that since we are dealing with speakers here. So first thing I'm going to talk about is frequency is equal to 1 over time period. So our time period in this sense today is 1 second. So to find out our frequency or hertz, we have to divide our time period by 1. For example, our time period is 1. 1 upon 1 is equal to 1. So our frequency would be 1. Same thing if our time period was 0.1, our frequency would be 10. If our time period was 0.001, our frequency would be 1,000. And so 22.6 microseconds of 1 over 22.6 microseconds, that's 44.1 kilohertz. Now, first thing we're going to talk about is our features. Now, an active buzzer only makes one sound, meaning that a car alarm, whenever you click the button, it doesn't sing you a song or anything. It's just one sound repeatedly. That's an active buzzer. It's just one sound where if you click it, it makes one hertz, it makes one frequency, and then that's it. And just to let y'all know, frequency shows us how many times it vibrates per second. This y'all don't need to know right now. But higher frequency equals higher pitch. So we can't control the frequency for an active buzzer. So that's why it only makes one sound. While for a passive buzzer, we can control the frequency. Meaning that with our Arduino right here, we could play Happy Birthday. I will show y'all how to do it later onwards, but we will play Happy Birthday and Jingle Bells at the end. Now, some differences between the active buzzer and the passive buzzer is that the active buzzer has an oscillator, which is basically it sets the frequency. It cannot be changed. If something has an oscillator, then it cannot be changed. We cannot change the oscillator, so it has a set frequency and we can't change it like literally. While a passive buzzer does not have an oscillator, which is why we can control the frequency and so the sound. And for an active buzzer, we have to use digital write in our code. It's basically, in the sense, kind of like an LED. LED just lights up, showing you that it's working, while an active buzzer, it makes sounds showing that it's working. So you're going to use the code that you use for LED for active buzzer. So we're not going to be really talking about the code of active buzzer since it's extremely simple. Just how would you write the code of an LED? It's pin number, and then high, and then delay, and then high or low. It's literally how you write the code for the active buzzer. But the passive buzzer does not have a digital write since we can control its frequency. It's kind of like the PWM. We can control how bright it is, so we're using something else called analog write. But we're not going to be using an analog write in a passive buzzer. So first, let me tell y'all the difference between the PWM and the passive buzzer. In the passive buzzer, we're literally changing the time period, while in the PWM, we're changing the duty cycle. Remember, duty cycle was how much time it was on and off. Well, in passive buzzer, we're changing how much its time period is. So that's the difference, which is why we're going to be using something called tone here. So as you can see here, tone. This is what I used for my passive buzzer, tone. So here's some functions that you can do with the tone. But here's another thing. Music, you can make that with the passive buzzer, but not with the active buzzer, since the active buzzer has one set one set sound and can't do anything else other than that, while a passive buzzer can make literal music. So the passive buzzer functions are this: so tone, pin, and frequency. So that's just like if you wanna like make it keep on going, make it stay, like if you're just testing it out, not really trying to make any music, then yeah, you can use this. This is just to make it turn on or off. So like if the frequency was 0, then it wouldn't be off, but if it was 10, it would make a slight sound, you know. While this tone, pin, frequency, and duration is what we're going to be using the whole time today. So buzzer is equal to pin number 8, so I just put that there. And this is how we're going to be using it today. So the frequency, remember, higher the frequency, higher the pitch. And duration, so it's in milliseconds, so 250 milliseconds is 2.5 seconds, I'm pretty sure. Or no, it's it's 2.5 seconds. I don't remember, but yeah. And no tone, that's just to turn it off. So we're not going to be using delay. Well, we will be using delay in this one, but you could also use no tone, that just turns it off. And yeah, and the diaphragm is what vibrates in the passive buzzer. So we're sending some pulses that vibrate the diaphragm, which then vibrates the piezo disc, which is basically what makes the sound in both of these buzzers. In the active buzzer, the oscillator sets the frequency, so the piezo is only going one speed and it cannot be changed. While in the passive buzzer, we can control the pulse with our electrical currents, so we can make different noises. So yeah, I think we should move on to how to wire one of these. So it's extremely simple. Now it is quite hard to see, but I just need this. Okay. So excuse me. So I don't think you'll be able to see it, but there's a positive sign on the left side of the passive buzzer. That means that side needs to be connected to the pin or power. And then the other side is, of course, the negative side. So that side's connected to the ground. And then that's it. There's nothing else to it. Then we go to the code. So first thing I did here was named my pin number 8 into the buzzer. And then I created the happy birthday song. I chose my frequency. So of course I'm not an artist. I don't play music. So this would have taken me weeks if I did it with no help. So I did use AI, so it would be much faster for y'all too if y'all used AI to write the code, as it is music that you're writing, not something that you can really control, or not something that you probably don't know. So I used ChatGPT, since that's like what I use all the time. But yeah, so basically just wanted to look something like this if you're gonna use AI and it creates you one. So this isn't the whole song, this is a part of the song. And I also created Jingle Bells, by the way. So yeah, so these both are a part of the song. It's not the whole song, because if it was actually the whole song, then yeah, that would just be too long. Now, I did put nothing in the white setup, but if you want, you could just write pin mode and name it as an output, but that's not really needed. So yeah, this is all there is. So you just want to make sure that it looks something like this: your pin number, your frequency, and how long it's going to be. So 5 milliseconds. So 0.5 seconds. So yeah, I think we should go ahead and start playing it. Let me just connect this thing real quick. All right. Give me a sec. All right. Okay. So I did have it on before, so y'all heard it a little bit, and now I'm just gonna play the whole thing all at once. And 3, 2, 1. Yep, so that's it, guys. Now, y'all might be thinking, well, that's only a really less part of the song. Well, that itself took me almost 100 lines of code. So, yeah, it's just better off to use ChatGPT or Gemini or whatever you like to write the code. But yeah, that's it for today's class. Quite short. Here's another look. Yep. So yeah, today's class was quite short and simple. Hopefully y'all enjoyed and learned something new. Bye-bye.